Alrighty, folks, so we are looking at page 497, 3 through 33. Today was a very fast day because of the snow, so let's do a quick review of all the problems that we have assigned to you for homework. So first one, number 3, what is the degree of that monomial? That degree of that monomial is 0. Does not have any variables, so any constant is going to be to the degree of 0. If we go ahead and take a look at 6, we have another 0 on our hands. That is the degree of 0. We have no variables, no exponents that we need to worry about. So that's a pretty boring section if we're doing every third. So let's take a quick look at number 2. That's going to be a 3rd degree monomial. Number 7, 4th degree monomial. Tricky fish in the bunch is number 4. That is going to be a 10th degree monomial, because even though y and w are different bases, we do have a product of multiple variables here, and we're going to go ahead and take all of them into account for the degree. Same thing here with number 5. That would be to the 4th degree as far as that monomial is concerned. So let's focus more on naming the expression based on its degree and the number of terms. Again, we went through this pretty quick, folks. So that's why I'm doing this review. Let's go ahead and take a look at number 9. We have 3 different terms, therefore it is a trinomial. The largest degree is squared, and it's just x in that particular monomial. So we have a 2nd degree trinomial. So the answer for number 9 is 2nd degree trinomial. Okay, that's for number 9. If we're going to go ahead and take a look at number 12, we have we really didn't talk about polynomials with variables. Well, you can't actually say that. Expressions with variables in the denominator, which would mean that 12 could be rewritten as 3x to the negative 1, right? We know that from our exponent rules. And we definitely did not talk about fractional exponents. The thing is with a little bit more time today, we could have. So now we're going to talk about it now. Polynomials. It's not going to be a polynomial if any of the terms have a negative exponent or a rational exponent, which means any kind of fraction. If you didn't know, square root of x is the same as x to the 1/2. Okay, so square roots aren't allowed. So we can't call it a polynomial. It's not going to fit the definition of a polynomial if you have rational exponents or negative exponents. So we can't give it a degree if we can't call it a polynomial. So this is not a binomial, number 12, because of that negative exponent. So let's go ahead again, take a look at some others. This is going to be a 3rd degree trinomial, 2nd degree binomial, 0 degree monomial, 1st degree binomial. All right, let's go ahead and clear that out. Again, you only have to do every third, but it doesn't hurt to do a quick review since you're watching the video. Okay, so now we're going to write each polynomial in standard form. We really didn't define standard form. Again, we try to fit in a lot today. Standard form, we're going to, in standard form, expect that the largest degree is to the furthest left with the declining or diminishing number of degrees as we go to the right. All right, so here if we look at 15, that's not quite in standard form. Also standard form has to be simplified. So 15, okay, there is no commutative property of subtraction, but there is of addition. So if we change this to an addition problem, we now have negative 3x squared. So 15 really is negative 3x squared in standard form, plus, because that's a positive 4x, plus 4x. So we've got this 2nd degree binomial written now in standard form. All right, next problem we're doing is 18. If we're looking at 18, it looks like it's already written in standard form, but we have multiple z squareds. So we need to combine those. Now, what I'm going to have you guys do is make sure that you rewrite this in your spiral so you know where your answer came from. So we're going to assume this is written in the spiral. To save time, I'm going to pretend that that is written right here, and I'm going to have my answer underneath it. Now, so 9 z squared minus 11z is going to give me negative 2z squared. Sorry, minus 11z squared. Now, we don't have any other 5z's, and we do not have any other constants. So now we have a second degree trinomial written in standard form. Muy bien? Okay, so again, quick look. Let's say we were to just look at number 20. We would have to move this up here, 4q to the 4th. Squared, we would have plus 3q squared minus 8q. And then there's actually no combining of any like terms, simply rearranging to get it into standard form. Standard form, we need the largest degree furthest left. All right, let's clear this out. And let's look at 21. So we're going to simplify each sum. Again, assuming you wrote this down in your spiral, write this down just the way it is. Pretty easy to add. If you look at this, this is just like a 2-digit number where this is one place value and this is another place value, except for with place values, you will have carryover. In this case, there will not be any carryover. There's no constants that we could have here that would end up giving us m squareds. All right, so that would be a unique, specific difference. So 5 plus 3 is going to give us 8 m squared plus 15. There's our answer there, second degree binomial. Easy enough. Let's take a look at 24. Again, after writing this down in your spiral, maybe not for this one, but for some other longer, if you're if you're adding very large polynomials together, not just binomials, trinomials, but you got a lot of terms all over the place, I would rewrite the addition problem with your like terms next to each other and cross them out as you go to make sure that you don't miss anything. All right, because sometimes as you're adding multiple terms together, where did this come from? What is that? Oh, it's a squared. There we go. Sometimes you might miss one. So if you look at your original problem and you say, okay, I've got 4 terms, I've rewritten them next to each other, and I have 4 terms, I'm in good shape. Then you combine them. So this is 24. 12 plus 8, 20x squared, 6 plus 1, 7. Second degree binomial. Okay, so that's 24. Let's go ahead and look at 27. I'm going to again rewrite this, looking for my largest terms first. So imagine copying this down exactly as you see it in your spiral so that you can do exactly this. I'm going to see 8y to the 4th. 8y to the 4th. It's the only 4th I've got. 7 plus 7y cubed. It's the only y cubed I've got. Minus 3y squared. Got another 3y squared here. And a 4y. Cool. Now I look for any common terms, and all I see is this here. So everything else is just a rewrite. 8y to the 4th plus 7y cubed. Funny, these just cancel each other out. Then I end up with 4y. So I've got a 4th degree trinomial. There's your final answer. Adding isn't the tricky part. The tricky part is finding the difference. Now for 30, they already set it up in the style that I said, hey, if you want to do it this way, awesome. Just make sure that you're careful with always referencing the minus sign. We're going to show how personally I prefer to do it in the next problem. But let's again assume that you wrote this down in your spiral, and let's give it a shot from here. So 7h squared minus 3h squared is going to give us 4h squared. That's the easiest one because you see the subtraction sign right next to the terms that you're subtracting, that you're finding the difference of. That one's nice. This one is a little less so. So you've got positive 4h minus a negative. So you got to capture that and say that's going to be like adding a positive, subtracting a negative, same thing. So I've got 4h plus 2h. That gives me 6h. All right. Here it's going to get worse because we got to go a further distance here. Negative 8 minus a positive 10. That's making it less positive, which is going to make it more negative, which means we have minus 18. So stacking it this way gets us to your answer faster, but does require that you always reference that negative. All right? Here, let's take a look at 33. Again, assuming you've written this down in your spiral, I'm going to rewrite it and distribute and get rid of the negative and turn it into an addition problem. So I would rewrite the first trinomial here, minus 3w plus 1. Now I would carefully distribute this negative. So this is going to be a minus w squared minus w. A negative times a negative is a positive, plus 9. Then, if I'm being really careful, I might rearrange all of my terms, or at least, circle and cross out my terms to make sure I don't miss anything. Look for my w squareds. I've got one here. I've got one here. So now I'm combining. Now I'm just worried about the signs of the individual terms. So 6w squared minus 1w squared, that gives me 5w squared. Cool, that's toast. Here I'm looking for w's. I see some w's here. I see some w's here. That is now minus 4w. Those are toast. I'm looking for constants. I've got 1 and 9. So that gives me plus 10. For me, I like doing it this way because I convert the signs immediately. Then I know I'm just looking at the sign next to the term and I'm combining like terms, which is just adding. That's my preferred way of doing it. However you choose to do it, because it's easy for you, please do it that way. Just show your work so I can see if you messed up where that mistake happened. So that's 3 through 33 odd. Thanks for watching the video. Hope that helped a little. Have a great night. See you soon.